Hello everyone, I'm Lokai Han, and today I'm going to present on the individual project MC-13 ARM Architecture and Programming Part 2. So in this project, we are required to design and implement an automated car park system using STM32 Nucleo board and the STM32 Cube IDE. So there are a few specifications for this project, such as there will be 200 parking spaces, and for the components, there will be an entry and exit sensor, 4-digit 7-segment display, as well as a green and red LED. So the green LED is the entry LED, the red LED is the exit LED. So first up, let's have a look on the concept. Yeah, so the first thing I want to talk about is the pin mapping. So this pin mapping is for the Nucleo board between the Nucleo board and the other components. So for the inputs, I have chosen PB1 and PB4 as the entry sensor and exit sensor input pins. So these two pins will be used as the interrupt, and I choose PB1 and 4 through trial and error because some of the pins have their default configuration and cannot be used as interrupt actually. So PB1 and 4 is chosen through trial and error. So for the outputs, I've chosen PC0 to PC13. PC0 to PC11 pins will connect to the 4-digit 7-segment display and to be used to control and display the 4 digits. PC12 and 13 will be used to control the entry and exit LED, which are the green and red LED. So that is the pin mapping for the Nucleo board. Now let's have a look at the circuit diagram. So I've drawn this diagram using draw.io, and yeah, you can see here on the middle is the Nucleo board, and there's pin connection based on the pin mapping table right here. Yeah, so I will skip through the pin connection, and if you look at this diagram, you'll see there's a 100 ohm resistors at the anode pins of the 7-segment display. So the D1, D2, D3, and D4 pins are the anode pins because I'm using a common anode 7-segment display. So these 100 ohm resistors are used for current limiting or current protection so that there is not too many current flowing through the 7-segment display and damaging the LED. Yeah, so they are for current protection. And for the red and green LEDs, I'm using a 1K ohm resistors and it's a pull up. Yeah, so I'm controlling them with a pull up resistors, 1 kilo ohm. So for the IR sensors, which is the entry and exit sensor, the connection is straightforward. There's nothing to talk about. For the BDD, I'm using 5 baud instead of 3.3 baud BDD so that the IR sensor can work correctly and the LEDs can light out and be visible enough instead of being dim. So I'm using 5 baud instead of 3.3 baud BDD. Yeah, so that is the circuit diagram. Now moving on, I want to talk about the mapping or decoding or coding for the 7-segment display. So here's a table of the 7-segment display coding, and you can see there are 7 pins A, B, C, D, F, G. DP pin is not shown because I don't really use it in this project, so decimal point is always turned off. And yeah, so here's the digit or alphabet that I want to show, or I want to display at the 7-segment display. And these are the codes that I need to send to the 7-segment display to get the result. Because I'm using a common anode, yeah, so when I set, let's say LED A to 0, that means that LED A will light up. And when I set LED G to 1, that means LED G will turn off. Yeah, so 0 means turn on, 1 means turn off for common anode 7-segment display. So this is a full table, and I've included all the digits and some alphabets that can be shown in the 7-segment display. There are some alphabets that cannot be shown or cannot be displayed that I have skipped through. Yeah, so that is for the concept. Now let's have a look at the code. So this is the main.c code for the car park system. Okay, let's quickly go through it. So this part is the default code, which the system come up by itself. This part is the user code. So this is the functions that I have written for the car park system. And this is the system default setting. Okay, so over here. So over here, I enable GPIO-B and C clock. And this part is the configuration for PC pins. I'm setting all the PC pins as output and setting them as a output push-pull mode as well. This part is the initialization. I'm turning off the 7-segment display by setting all the bits, PC bits to 1. Basically just turn off in the beginning. So this part is the interrupt. I disable the IRQs globally, and then I start with the PB pins interrupt configuration. First I set First I set PB pin as the input. Actually I only use PB1 and 4 pins, but I set everything as input. Then I enable pull-down resistors for all the PB pins. This is internal to the this is internal to the Nucleo board itself. That means I don't really put a pull-down resistor outside at the sensors. So this part enables the interrupt. So this part select port B for the interrupts EXTI1 and EXTI4. And port B because I'm using PB1 and PB4 pins. And then this is the enable, EXTI enable. This is the falling edge trigger because I want it to turn on when the input is low. And then I enable the MBIC and enable the IRQs back globally. So the count here is the number of parking space available, and this is the initialization. Initially, it will show I and the initial of my name L for about 5 seconds. After that, it will move into the infinite loop and always show the number available, as in the number of parking spaces available. So that is the main function. So this part is the system default function. This is the system default. Let's skip through the user code. Okay, user code functions. So these two functions are the EXDI interrupt handler functions. So for ESTI1, if it is triggered, that means that the let me double check. PB1 should connect to the entry sensor. Yeah. So when the entry sensor is triggered, the PB1 or ESTI1 will be triggered as well and triggers a interrupt. So it will jump to this interrupt function, and I will turn on PC12, which is the entry LED, which means I will let the green LED light up for a few seconds. And this is still displaying the number of parking spaces available. And then, yeah, so, display the number of parking spaces available and turning on the green LED for a few seconds. Then I will turn off the green LED and decrement the count by 1. That is because there's one car entering and there's one less parking space. And then I will clear the interrupt flag for ASDI1. So the count will reduce by 1 and it will return to the while loop and keep showing the latest count. So similar applies to the ESDI4 handler, except that this is for the exit sensor. And when the exit sensor is triggered, the red LED will light up for about 2 seconds. And then the count will be increment by 1. That means there is one more parking space since one car has left. And then I will clear the interrupt flag as well. So that is the interrupt handler. So next is the letter mapping. So this is basically the table that I showed just now. The 7 segment display table. Yeah, so if you compare between the C code and the table, you will see is the same, except that I convert the binary to hexadecimal. Yeah. So yeah, this is basically mapping for 1-digit 7-segment display, and it is common A0. This is extra features I add in case there is a character that is not available. The 7-segment display will show error. So this function here, map number, is used to map the 4 digits of the 7-segment display. Basically, it will call the map letter to display for 4 times so that it can show digits on the 4 digits. Yeah. Oh, sorry, only 3 digits because we only have 200 parking spaces, so only the last 3 digits are used. So the input will be an integer number between 0 and 200, which is the parking space count. And if the number is 0, it will jump to a function to cycle through the word full. This is the project requirement. We can talk to later. We'll see the function. If the number is bigger than 0, which means between 1 to 200, the code here will will automatically map the number to the 7-segment display output and show the digits. Yep. So this part is basically turning off each digit one by one and writing the output to each digit. And there's a 100 millisecond delay in between. This is a very short delay to make it seems like the 3 digits are lighting up simultaneously. Okay, so next is the map string. So the map number here is used to map integer digit to 7-segment display output. So the map string here is used to map a 4 character string to the 7-segment output as well. So the concept is similar to map number, except you need to convert, you need to split the string into 4 characters and yeah, again, map and display it one by one. Yeah. So the next function is the cycle through full. So if you look at the project specification, it mentions that if the parking lot is full, which means 0 spaces, we should display and cycle through full with a few millisecond delay on the 7-segment display. So this is the function to do it. It's quite straightforward. Yeah, I basically just cycle through it one by one. It's quite straightforward. And yeah, the last function is the delay function. So delay by millisecond, and it is straightforward as well. The input is how much or how long you want to delay, and I will put it into a for loop and loop through. Yeah. So the rest is system default codes. Yeah. So that is it for the code. Now let's move on to the demonstration. So here is our car park model. Let's go through the components over here. So over here is the 4-digit 7-segment display. And here is the green LED, which is the entry green light. Here is the red LED, which is the exit red light. And here is the entry IR sensor. Here is the exit IR sensor. So what we expect is that when a vehicle passes through the entry point, the green LED will light up for 1 second, and the 7-segment display will display the available parking spaces, and the car will decrease by 1. And when the vehicle exits through the exit point, the red LED will light up for 1 second, and the count in the 7-segment display will increase by 1. Without further ado, let's start our demonstration. So my name is display, hi L, and here is our initial parking space count, 200. So I don't really have a model car with me, so I will be using some toy cats I have. So let's try out. Let's say a car enter the entry point. The green LED lights up and the count decreases by 1. And when a car exits through the exit point, the red LED lights up and the count increases by 1. So let's try again. Yeah, so that is it for the demonstration of the normal operation. So here is the demonstration for the full operation mode. Let's say we have one parking space left. And when the next vehicle enters, let's see. So there is no more parking space left, and the 7-segment display will cycle through the word full. Yeah, so that is it for the full operation mode demonstration.